Hello, everyone, and welcome to our webinar, Understanding Varnish Logging and Intelligence. I'm Alexander Barcelona, U.S. Marketing Manager, and I will be today's moderator. Before we jump in, I'd just like to touch on a few housekeeping items. Today's webinar is being recorded and will be made available to everyone who registered. We'll be taking questions throughout the webinar, so please add them into the Q&A panel on your screen. We'll also have a Q&A forum at the end where we'll open it up to live questions. So if you have any other questions you'd like to ask, we can answer them at the end. So to start, I'll go through today's agenda. We'll be starting with introductions. We'll go into logging internals, debugging, accounting, building your own tools, and then the open forum at the end, like I mentioned. So let me start by introducing today's speakers. We have Guillaume Quintard, who's a senior engineer at Varnish, Andrew Wick, who's a software engineer, and myself, marketing manager. So with that, I will hand it over to you, Guillaume.
Thank you very much, Alex. So we are going to be together for roughly an hour. And before we start diving into the technicals and the specifics, I just want to start with a short reminder. Pretty much everyone around here will probably know, but just in case. What is Varnish again? We started as a caching server to replace Squid originally, but we have since grown and expanded our horizons. We are still a reverse proxy for HTTP, and we still do caching, but we do much more, from load balancing, TLS termination, to token validation, and others. The important part, and what hasn't changed, is that we are still between your users and your origin servers. We make the traffic faster, but we can also manipulate it to sanitize it, check it, transform it. And this is why this webinar is very important regarding logging. We handle hundreds of thousands, or sometimes millions of requests per second. So it's extremely important that we are able to report about what we see and what we did about it. And as you're going to see, the old way of logging didn't really cut it. This is why we had to change it. So let's see first how things are done currently and how we change them. And the way we log has been shaped by decades of Unix culture, which is absolutely fine, but it's also sort of limited. Usually when we log, it's to a file or standard output, or if we are feeling fancy, we log to a syslog facility. And we do so with one item per line, which is pretty good if you want to grep your logs to find something in it. But at the same time, grep is not the best tool to filter logs. So we are sort of locked into uncomfortable balance between wanting to have structured log. This is where the JSON CSV comes from, and having something that is human readable. So basically here, because we have a lot of information, we want to do something that is a bit more efficient. And the second very important point is going to be performance and IO bottlenecks. When you don't have a lot of traffic, or you don't have a lot of log lines to spew out, it doesn't really matter. But when you're dealing with millions of requests per second, even if you only have one line per request, that is still an enormous amount of data to write on disk or even on the network. And because we are a high performance server, we don't want the fact of reporting on the action block the action itself. So we needed something better, asynchronous, and basically we solved that that conundrum by saying that Varnish doesn't need to log. Instead, it's going to write as much data as it can to a in-memory circular buffer. So basically we just write into the RAM in an area, and if we reach the end of that area, we just start at the beginning again and we start erasing what we already have. That doesn't do much, but it allows us to push enormous amount of data and very complete data, as we're going to see later on. And that is completely non-blocking. On the other side, on the right of that diagram, you can see that we have multiple readers. They are going to basically watch that, that Varnish shared memory space and extract information as they see fit, possibly format it, and then export it, generally as the old way, to the standard output or to a file or a syslog facility. But the important thing here is that they are going to read without blocking the critical path. And you can have as many readers as you want. They can come and go. You can start multiple NCSA logs, for example, with different configurations. And basically Varnish, the main process, doesn't need to know anything about them. So with that on the table, what do we put in that VSM component? Very simply, we are going to push binary blobs. And I know the general sentiment of the crowd usually is that binary logs are bad, but hopefully by the end of that presentation, I will have convinced you a little bit that there are really good benefits to that approach. So what do we have in a record? A record is basically a log line. The meat of it is the content. So you can see it as an old log line, basically. And it has 2 bits of metadata that are very important to us. The first one is the tag, which is basically a category. Here, the example is a response header, but it can also be a request method. It can be a status code. It can be timestamped. We're going to see a few examples later on. And the second bit of information that we really want is the VXID, which is a fancy acronym for just transaction ID. Because a transaction being a request from the client, a request to the backend, a TCP session, it's basically a block that is going to contain a lot of records. And this is where we start departing from the status quo. We have inside a transaction tens or hundreds of records. So the amount of information that we log is an order of magnitude or 2 above the usual. And we're going to see how we can use that to our advantage. And without further ado, let's go with Varnish log. But before that, Andrew, do we have questions?
Currently, we do not.
Perfect. I must be very clear. If I'm not, please ask a few questions in the chat. So we are going to go with Varnish log for 2 reasons. First, it's the least abstracted tool that we have in our suite, and this is the one that's going to give us almost a unmodified access to the logs. And so if we understand Varnish log, then everything is pretty much based on it. So it's going to be a breeze. To give a bit more practical approach here, I'm going to share my little setup. This is really a synthetic test setup, but that's going to allow us to manipulate a little bit so that, yeah, we have a better feel of what's going on. Very simple setup. I have on the bottom right a Varnish server that is currently running. You can see that we have the old way of logging just for system information. And it just gives us basic information about the process itself, but nothing about the traffic. Varnish is fronting a Python simple server, so I just have a couple of cute pets images that are being served through Varnish. My VCL is relatively simple. It fits on the screen. And this is not a webinar about VCL, but just to give you an idea of what's going on, we are going to force a cache miss every 10 requests. We are going to normalize the URL. If we see a cookie, we are going to bypass the cache. Otherwise, we are going to look for the object in the cache. When we receive a backend response, we are going to set a header using the file name in the path. We log a tiny message, we set the TTL, and then we deliver. And in the deliver step, which is right before we send the response to the user, we are going to add some metadata about the cacheability and the number of hits that we got on the object. And that's about it. On the left, you can see the actual Varnish log, basically almost as it is in memory. I'm just going to Control C it so we can see better. There we go. And you can see I didn't lie in the example. We do have an ID. We do have the category. That little C is for client because we also have transactions that are going to be on the backend side. So we would see a B here. And then you have the content that is going to change. It's nice, but it's a lot of information. It's not really structured. So that's not super useful for a human. Thankfully, we have a few special records, which are going to be the begin and end ones. And basically, that is going to allow readers to aggregate the data into transaction blocks. And this is what Varnish log is actually going to do by default when you run it. And it's all live traffic, synthetic, but still live. And so you can see, for example, let me set to scrolling. Good, so that we see everything. You can see my request here. The ID is now at the top because we don't want to repeat that for each line. But we can see that we have a begin. We have that begin record, and at the end we do have the end. Interestingly, we have some information about what kind of transaction is going to be. Here we can see that it was a request. It's also originated from a request that we actually received, because that could be an ESI sub-fragment, for example. And we can see that we have an ID here that doesn't match the one on the request. It does, however, match the ID of the session there, because the two are linked. A session, as you can see in the begin here, is an HTTP session, so a TCP session. It could be an HTTP2 one. But that HTTP session is basically telling you, hey, inside this session, you have multiple requests. And notably, we can see that 868 here is actually the last one in the TCP session. So with that link record, we are starting to see a little bit more of that structure. And we can actually ask Varnish log to aggregate those following the links. This is done using the -G for grouping argument. And we are going to ask it to do that by session. And we can see that we are going, if we scroll up to the top, we are still going to see our session. We still have the links, but at the back of it, instead of an empty line, we have the included requests that are in there. And you can see they have an extra level of indentation. So we are really creating that tree structure, and you can really see who is starting what. So that makes things a lot more readable when you're trying to understand the structure of how things went. But that structure is generally not enough. You are interested in what's inside it. And because VCL is a programming language, it's super important to try and understand what's going on. And we have a almost one-to-one correspondence between what's happening in the VCL configuration file that you can see at the bottom of the screen and what is being reported in the logs. And that's a nice example, but we can also check it out here in, for example, if I check the VCL receive, I can see here, okay, that was a request. I got a get. There was my URL was a author.webp with an ID as query string. I can see the host headers and all that. And I can see here, I'm entering VCL receive. I can see the request is being rewritten at the URL level. And then I have a return hash. And the same way, if I scroll down a little bit, I can see my VCL deliver. So I enter deliver. The cacheable header is being set, and here it's being set to yes, and the opsheet, and then I'm returning deliver. So it's really important for us because we're basically writing a little program. You can name it edge programming, but the VCL is typically a way for you to program the logic of the cache. And having something that is going to tell you, okay, what's happening, how it worked, and what decisions were made are extremely important. Now, that was for the logic. We are also interested in the performance. And for this, we are going to be interested in a couple of records, namely the timestamps and the accounting ones. That sounds barbaric and scary, but it's actually super easy because they are basically all the same. A timestamp is going to start with a subcategory telling you when the timestamp is being applied. So start is at the beginning, at the start of the block. BERESP is when we got the headers from the backend. BERESP is backend response. And BERESP body similarly is BERESP backend response body and it's when we got the last byte of the response. And the first number is the absolute time that we have the timestamp, and the second one, which is usually the one you want because that's the most useful metric, is the time since the beginning of the transaction. In the BERESP body, it's basically the time to last byte for that response. That's for the time. You're also probably pretty interested in the amount of data that you sent. And here you have the backend request accounting and the request accounting on the client side. And it's going to break down the amount of request, body, and total bytes that you got, both for the request and for the response. So this is another way we provide more information than most servers. Because we are reverse proxy, we basically have two sets of transaction on the client side and on the backend side. And here you don't have to decide if you want to check the backend version of the data or the client. You can get both. That's pretty important because you may not have been able to push all the content that you got from the backend to the user because maybe they disconnected or there was a problem, or you realize that there was an issue with the content that you were delivering and you're just blocking the the traffic for security reasons. So that gives us a lot of information here. And as I said, a lot of information, and you probably don't want to do it like we did here, just watching walls of text scrolling up. That information is amazing, but you probably just want to save it somewhere and then be able to reread it afterwards. Of course, we got you covered. Varnish log has that very nice ability to be able to write to a file, which is pretty cool. And we are going to keep the data in its binary form. That's going to be super useful later on. Also, and that's pretty interesting, because we have a circular buffer, that means we have pretty much a backlog of all the stuff that we haven't erased yet, basically. And we have access to that with the -d argument, where we are just dumping whatever we have in memory into a file. And same thing, we can have it in binary form. That is pretty interesting because we are going to be able to reformat the data as we see fit. If we try to reread that log file, for example, I'm going to do that in ls. I have my logs, I'm fine, that's expected. But I can also change the grouping if I want. So I'm saving the raw information, and then the representation is up to us. So when you're debugging, it's super important, and that -w to write and -d to dump is basically one thing we do with the tool Varnish Gather. It's on GitHub. I definitely recommend it because it's an amazing tool to do an offline analysis of a server. If you have an issue, you just run the Varnish Gather. It's going to run for a couple of seconds. It's going to bundle everything in a nice tarball, and then you can take it home and try to see if something's wrong. We have other little niceties, but yeah, that's the brunt of it. Saving and dumping is very important because yeah, you get the whole information. That's great, but you also need to find the information. And as I mentioned here, grep is not a solution because there are way more than one record per transaction. So instead, we have a query language that you can access using -q. And basically anything you see in the Varnish log is going to be available for filtering. And going to show you a very simple example here. On the web browser, we could do that with curl, but I mean, we have nice graphical tools, so why not use that? I'm going to try and reach one of the images that I have on my server. And if I go to it, it's a very cute dog. But while the categorization is good, which it's nice, it's indeed a dog, I'm a little bit worried about that cacheable no. This was the header that we pushed when we received that, before sending the response. And everything should be cacheable. So we want to see, we wanted to see what was going on. So one thing that Varnish does is it gives us the ID here of the request, and we can actually try to grab it. I may have waited a little bit too much because there's a bunch of traffic here. No, so we still have that. We still had that request in the backlog, so we can have a further look at it. And we can see that we entered VCL receive. We can see that the request was normalized, but it was already this anyway. And then we return pass. So it was a conscious decision from the VCL to actually pass and sidestep the cache. If I have a look in my VCL, the reason for that I can see is because there is a cookie. And sure enough, if I scroll up, that gigantic blob of text is actually a cookie header. So this happens because my browser is a little bit confused because I'm reusing localhost for a ton of different stuff. So a cookie got through, and basically my browser thinks that cookie is relevant for this specific server, which is not. So I'm going to fix this very simply. Instead of bypassing if there's a cookie, I'm just going to unset all cookies because those are just pictures of dogs, cats, and otters. So the cookie is actually not relevant. So I'm going to fix my VCL right now. Reload with the very trusty Varnish reload. And when it's done, I can go back to my web browser, try it again. And I can see that I'm now still a dog, but more importantly, cacheable, and my hit number is 5. And you're probably going to argue that I could have, if I thought a little bit about it, I could have checked the headers in the developer tools and saw that, okay, there was a cookie, that's my mistake, and I should go to the VCL and try to see what's going on. But here the VCL is fairly small. So that was fairly easy to just have everything in mind. And at the same time, I don't necessarily have access to user logs. And what I see in the Varnish log are what I see in the developer tools, but I see also more, namely the decisions that Varnish took to handle that specific request. So even if I had access to the developer tools, I would probably still go to the Varnish logs because there is more information here. And yeah, I'm going to end on that for Varnish log, but you have multiple ways of using it. As we did right now, there's an issue. We just try to acquire some information, possibly filter it, maybe do it live or use a dump. Varnish gather, as I mentioned, I mean, if you're using Varnish, do use the Varnish gather. It's open source. It's just a shell script. We take pull request. So if you feel that there's information missing in the gather, please let us know. We'll be happy to add it. And the last one, it's pretty interesting one. It's not always used, but it's great when it is. We can use the Varnish log as a daemon that is going to log only the faulty requests. So the ones that take too long, or the one with the bad status, or the one with a backend error. And we can also rate limit the output. So that allows us to have a watcher that is going to give us a lot of information about the faulty traffic without filling up our disks with logging information. And of course, Varnish log is log rotate friendly. We are going to change the file when we receive a SIGUP and all that. I mean, it's standard Unix administration, but we just fall into the steps of the previous architects here. Before we move to Varnish and CSA, Andrew, do we have questions?
We currently do not.
Perfect. Great. So we are moving to Varnish and CSA. Varnish log was great because it collected all the information, and that's probably a bit too much. So Varnish and CSA allows you to do exactly what I said was bad at the beginning of the talk, meaning it allows you to have just one line per transaction. So compress, squash all that info into just one line for easy processing. And that's absolutely right. Varnish log is debugging information. It has a tremendous amount of data in it, but most of the time you just need to know who requested what at one time and how much data you pushed and how long it took. And that's it. And Varnish and CSA is going to do that by default. You're seeing here an example of the default format string. But the important thing is you can build your own. And Varnish and CSA, as the name implies, is basically a copy for Varnish of the Apache NCSA tool. So we have much of the same specifiers. So we can basically take a format line from NCSA and just have it work inside Varnish. But there is something even better, is that whatever you see in Varnish log, you can find it in Varnish and CSA. Just to give you an idea, let's see. I'm just going to dump that log so we can have some working material here. And we are going to build a tiny format string with normal specifiers, but also that extended one that I showed you. So very easily, we are going to do a Varnish and CSA -f for the format string. I'm interested in the IP of the user. I also want to see the path, and I want to see the query string, just in case. And on top of that, I'm interested in this little guy, the process timestamp. This is the amount of time it took us to find the object. Not necessarily send it, but to find it, either in the cache or from the backend. And this is not something that we have a specifier for, so we'll have to dig it up. And it's actually super easy. Percent curly brackets and an X, and we are interested in a VSL. It's a timestamp. We are then going to specify the type of timestamp, process, and we are not interested in all three of those, which is basically what's going to happen if we just stop there. We are only going to be interested in the time since the beginning of the transaction. So we just add a little 2 here. And if we run, then we're good to go. We can even make it look good with some tabs and all that, but it's really just a matter of formatting that string. And just like that, Varnish and CSA is bringing us back to the regular Unix world, where you're going to write to a file or a standard output. We can demonize it. We can do pretty much whatever we want. It's just a matter of formatting that string and then pushing the result wherever we want. That means if you want to create a JSON object, for example, that you want to push to Splunk, that's completely doable. And if you just want to have a comma separated value string that you're going to push on disk, totally possible too. It just makes it compatible with all the exporters that you currently have, but you can also dig out anything that you see in the Varnish log. Is there any question thus far?
No.
Good.
You're doing a great job.
Thank you, Andrew. That means a lot. We are nearing the end of the session, and I just wanted to say a few words about plugging yourself in there onto the logs. Most of the time, you're probably not going to need it because Varnish log has JSON output. You can create JSON output with Varnish and CSA. You can. A lot of the collectors are basically made for the way Varnish and CSA works. But if you want more speed, more power, and you want to build your own stuff, it's super easy to do. And here I want to showcase the Varnish Go bindings that you can find on GitHub. It's the Phenomenus repository. It's really a toy example just to show how easy it is. But to give you an idea, this is a full program. I'm just importing the bindings. There is some boilerplate just to make sure that we can open the Varnish shared memory. And then while that one is actually a bit cryptic, it's really just, do I want a query string? Here, I'm just going to grab everything I want. I'm going to do everything I can, sorry. Here, I'm going to group the request by ID, so the regular transaction grouping. And I'm going to read everything live. And then I'm giving a little handler function that is going to do just one thing. Grab either the rec URL or the brec URL records, and then print them in either green or red, depending on client or backend. And otherwise, I just do nothing. That was 27 lines of Go, and unsurprisingly, it works. But you can definitely see that, okay, this is the client path, which hasn't been sanitized. You can see that we still have the query string. And on the backend side, you can see it has been sanitized and it's red. And yeah, we have roughly that 1:10 ratio that we set in the VCL. I won't go too deep into that one because I mean, once you have the bindings, you can start putting that thread. If you don't have bindings for your favorite language, not a problem. You have Varnish log JSON output. Brace yourself because it's going to be a little bit verbose. But if I just do -s, I'm getting line delimited JSON that I can then ingest with whatever JSON enabled tool. For example, JQ, since it's my daily driver. And you can see it's extremely verbose, but you keep the structure where you have the tag, you have the value, you are keeping the links. So, and you keep the grouping. So if you just want raw logs, you can have that. If you want them grouped by TCP session or by client backend request, you can also do that. It's a little bit heavier, of course, because you're moving more data, but at the same time, it's JSON, so you can ingest it from pretty much anywhere. And that's it for me. Do we have questions, Andrew? Please help me here.
Yes, we have one. We have a couple now. Can Varnish transactions on multiple web servers be correlated by overall HTTP session if the Varnish log data is send/pulled to a single source?
So yes, this is an interesting question. The answer is going to be no, for one easy reason, is that if you are if you are using multiple Varnish servers, you are going to have multiple sessions because you can only establish one TCP session to one particular Varnish node because of the way TCP and HTTP works. That being said, you can definitely identify your users if they are using cookies, for example, which is going to be an overlay session on top of TCP and HTTP. So if you have a unique identifier in the request, the dreaded JSession ID, for example, in PHP, this is definitely something you can do. And once you've identified that ID, then you can sort through that in Elasticsearch, for example. Justin, does that answer your question? Let's hope so.
Next question is, what is the performance impact of running Varnish and CSI / Varnish log, and what is the best practice to minimize those impacts?
So the biggest impact is really going to be the amount of disk that you use to write the disk to and the network. I mean, this is really what there is. In terms of CPU, shouldn't be that big. It's probably going to take, I don't know, 10% of a core or something like that. It's going to vary depending on the amount of requests that you get. But usually it's fairly minimal. We have customers running 2 or 3 NCSA, basically one for the client request, one for the backend request, another that is pure JSON and that has too much information, but that you really need, and a Varnish log that is doing the collection for the faulty requests. So, and it works absolutely fine. On top of that, Varnish is also extremely frugal in terms of CPU, so it's rarely an issue. To minimize the impact, I would always say for Varnish log mainly, because Varnish NCSA is, I mean, it's one line per transaction, so it doesn't cost much. For Varnish log, which can produce an enormous amount of logs, I would say try to filter the stuff that you know you're not going to need. Also, Varnish log allows you to filter the type of records that you want. So as an example, if I do -I and I say, okay, I'm only interested in the response headers and possibly also the request URL. So if I do that, I can get something that is a lot more lightweight than that needed. But in terms of processing power, it's usually it's fairly small. Does that answer the question? Good. I'm seeing Abiram raising his hand. So Abiram, you can unmute yourself and go ahead.
I already asked my question and somebody responded in the chat, so I'm good with it. Thank you.
Perfect. All good.
Okay. If there are not any more questions, I think we can wrap it up. But again, just a reminder, you can submit questions into the Q&A panel, or you can also raise your hand if you would like to ask your question live. If you have any questions later or come up with anything, you can reach out to us on our website and contact us there. Just a reminder too that we have recorded today's webinar, and everyone who has registered will get a copy of the recording to review later. So again, if you're watching it later and you have other questions, you can always reach out to us. But I think with that, it doesn't seem like there are any more coming in. So with that being said, Guillaume, thank you so much for this, and Andrew for your help as well. and we look forward to the next one. Thank you so much.
Thank you very much all.
Thank you.